Thank you for confirming our webinar titled Machine Learning for IT. My name is Patrick Moran and I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speakers. Vinod Iyengar is VP of Marketing and Technical Alliances at H2O. He leads all product marketing efforts, new product development, and integrations with partners. Vinod comes with over 10 years of marketing. Ronak Chokshi is responsible for industry vertical solutions and product marketing content at H2O. Prior to H2O, he was product marketing lead at MapR Technologies. Ronak comes with 15 plus years of experience with cross-functional roles in startups, mid-sized companies, and large corporations shaping solution strategy and leading go-to-market execution across a variety of industry verticals. Before I hand it over to Vinod and Ronak, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the questions tab. We'll be happy to answer them towards the end of the webinar. And this webinar is being recorded. A copy of the webinar recording and slide deck will be available after the presentation is over. I'd like to hand it over to Ronak and Vinod.
Hello, my name is Ronak, and in this 1 hour, we would like to go through a few things here. I'll give you a bit of an overview of what we're going to talk about in this session. We'll talk about some challenges and imperatives for as enterprises adopt AI. We'll talk H2O platforms and how we are enabling IT and DevOps in this journey for our customers. And then we will show some demos. All right, so moving on. An overview, right? So we all know that AI is pushing the boundaries for enterprises today, regardless of your industry. Predicting machine failure, preventing diseases, anti-money laundering, fraud prevention, and so on. So we also know that organizations have formed dedicated teams, data science, data engineering teams to solve these problems. And each one of these are data-driven use cases as we see them. And as a result, you need high-quality data to train the machine learning and AI before they go into production, right? But deploying these AI-driven use cases requires IT support. So throughout this process,
and just to add to that, right, we always talk at H2O about the idea of data science and machine learning being a team sport. And as Ronak mentioned, typically a lot of the focus is on the data scientists, the data engineers, but IT and DevOps are equally important, if not more, parts of this equation, because eventually what actually makes into production or what gets used in making an impact is dependent on how these models or these machine learning outputs of machine learning and data science workflows get applied. So that's one of the critical reasons why we chose this topic, and we are focusing on how data science can be aligned with, and basically IT professionals and DevOps folks can start to think about what tools, what best practices, and what are the considerations they need to look at before implementing these models.
Right, well said. So, so this slide shows our understanding of the role that IT and DevOps plays in this process, right? They're very important to this journey, and they are responsible for providing the data, managing the infrastructure, and then that's the start of the process. The data science team, the data engineering team help with preparation of the data, ingestion, building the models, training them, validating them, and then once again it comes back to the DevOps and IT for deploying those models and then further monitoring them. So this looks like a short process, but we all know that this is a very sophisticated process, and we'll show during this session how H2O products are enabling this journey for the IT and DevOps teams. All right, so these are some of the things that we know that the IT team is up against, right? You have to, as an IT leader, you have to manage the infrastructure, which includes provisioning your infrastructure, administering it, enabling multi-tenancy, enabling deployments. There's a lot of security, data security that goes into managing this infrastructure. There is very sophisticated governance that needs to be handled, especially with in regulated industries and so on. There's integration aspect. Your organization, your enterprise often runs hundreds of applications, and all of that has to be integrated into the process. As new use cases are implemented, new business, new models are built. And then containerization. So obviously we are now in a time where Kubernetes deployments are widespread. Applications are becoming more and more portable. So that once again lands in IT's lap to manage the containers.
Yeah, just to add to that, and this is true for most IT workloads, not just analytics and data science, but especially true here, partly because of the fact that data science and machine learning is changing at such a rapid clip. The frameworks, the tools that were used, say, 5 years ago are kind of obsolete now. There are completely new frameworks, new tools. Like for example, in the last 5 years, different set of algorithms, like more tree-based methods, deep learning-based frameworks, and they are being used more widely across the organization. And these require a completely different set of architecture to deploy, not just for deployment, but also for training, right? So part of what Ronak touched upon in the management, which is provisioning of instances. So for example, now you have to provision, going from sort of commodity hardware in the old Hadoop era to now more HPC type of hardware with fast CPUs and GPUs, maybe have fast SSDs, so that the data read and ingest rates are much higher. And then similarly for deployment as well, considering the use of dedicated inferencing engines like GPU T4 machines, T4 chips, or even some of the new latest Intel CPUs. Those are all considerations you need to think about. And as these frameworks keep changing or updating, are there still best practices? Are there still sort of underlying guiding principles that you can use to make sure that you are up to date, you're supporting your organization as data scientists? Because data scientists continue to try new algorithms, new frameworks, and they want to be able to deploy them. So how do you support all that without losing your sleep, I suppose?
Right. Now coming to data access, again, there is when you think of when the business teams and the data science teams have to implement and put certain use cases into production, you have to pull data from all kinds of sources, and the data itself is varied in terms of its types. So they could be machine logs, they could be sensor data, transaction logs, etc., right? And then in terms of sources, the data could be sitting in any one of these cloud providers, or Hadoop, on-premises, or applications, and so on. So it's a very complex landscape that you're dealing with as an IT leader. All right, so going into the operational simplicity. So I spoke about the data science process and involvement of IT in this process. And these are the things, the table at the bottom of the slide are the things that you would have to consider, meaning when it comes to installing new software, it has to be simple, it has to connect to applications, it has to account for on-premises as well as cloud infrastructure, same thing with management. Upgrades have to be managed, they have to be seamless. There has to be enterprise support available for the upgrades in case something goes wrong. Rollbacks. Monitoring is a big thing, because you don't want resources idling and your IT bill goes up high at the end of the month. If there is drift or anomaly detection, specifically with models, then that is something that the DevOps team is concerned about. Security, I mentioned that earlier. And lastly, governance. There is data traceability and model traceability, along with policy management that is that is very critical, like I said earlier, in regulatory heavy industries.
Yeah. So basically, if you think about this, there's three big objectives for IT or the IT organization, right? So first is increasing the productivity of your enterprise. So meaning making sure that your data scientists, your users are able to operate at the best, most efficient level, which means they have access to the latest versions of the software, they have access to the best possible hardware, so their compute cycles are much lower. The second is management of cost. So most IT organizations are run as a cost center, so there's always a big pressure to make sure that they are optimizing resources. And how do you do that? You making sure that you're fully utilizing all the resources you have at hand. So using best practices to avoid idle time or idle resources, or even unused resources, making sure that those are reduced. At the same time, also making sure that you're making the right choices around what frameworks to use, what platforms to use, so that you can distribute the workloads if possible. Instead of buying a lot of new hardware, I can use existing hardware to do more work. So those are all considerations. Similarly, build versus buy, right? So often you can build your own on-prem data center, but hybrid is kind of the new game in town. Because it doesn't make sense to keep procuring hardware when you have these spiky workloads. Machine learning workloads can be extremely spiky. You might have need like a bunch of GPU farms just to run a big experiment, and then you don't need them anymore. So in those cases, maybe you're better off just running them on cloud for a while and then collecting the results back. So resource management is often a big part of what you do with managing costs. And finally, the third big, probably equally important, but often much more important for regulated industries is risk management, if not risk avoidance. And what does it mean? So you don't want, the last thing a bank wants is a breach. The last thing a healthcare firm wants is privacy breaches, right? So you making sure that your access control governance practices are really rock solid, but at the same time ensuring that the easiest way to prevent risk is to not do anything, right? So you can shut down everything and you won't have any work being done, which is why I say it's risk management. So you still need to allow your data scientists to be able to make use of the data to build models, but at the same time put best practices in place, put policies in place that can avoid even unintentional, like often it's unintentional, right? Unintentional breaches, unintentional data sharing. So these are obviously three sort of orthogonal objectives, but they have to come together, and that's the goal for all the IT organizations. And this is especially true of when you're helping support the data science workload, data science and machine learning workloads.
Yep, that's an excellent summary. All right, so coming to our product suite, right? On the left here are two open source products. You can look them up as well. The first is an H2O, what we call H2O Core. This is 100% open source, licensed by Apache version 2. This is built for data science teams. And the second is called Sparkling Water, primarily where the H2O runs on Hadoop and Spark deployments. And on the right here is Driverless AI, which is a commercial software, primarily, it's an enterprise-ready software and built for data analysts, data engineers, data scientists, domain scientists, and so on. And we'll show Driverless AI in a few minutes when we get to the demo. This Driverless AI primarily enables fully automatic machine learning. So everything from feature engineering, model development, hyperparameter tuning, deployment, model management, and monitoring.
Yeah. And both H2O, open source Sparkling Water, and Driverless AI, these are enterprise-grade softwares. These are built for the largest banks in the world, largest healthcare telcos in the world, and they're used really widely across all the Fortune 500 companies. And what it means for you as an IT professional or an organization enterprise is that we have taken care of all the required practices on security, around governance, but also making sure that these softwares can run inside your IT setup. So whether it's on-prem, cloud, or hybrid, and we'll look at all of those in a little bit more detail. Yeah. But we have ensure that these work well with your existing ecosystem of products. So this is built to fit into whatever else you have set in place.
Yep, that's the next 3 slides. So this is Driverless AI, and how it benefits IT. So just like Vinod mentioned, you get the flexibility to deploy in any of the 3 major cloud providers as well as on-premises, and we'll show that in a second. You can ingest data from a variety of cloud object stores, on-premise data stores, etc. Security through Kerberos, LDAP, and SSH. All kinds of third-party algorithms included, and deployment flexibility, along with monitoring and management, and a very convenient upgrade mechanism. So as you can see, this is ideal for making your own AI across any of the cloud or on-premise environments. Sorry about the slide here, but so this is Enterprise Puddle. This is unique for instances where you want the flexibility to spin up instances of driverless AI in any VPC, any virtual private cloud environments. So again, the same controls, the same flexibility that you get with driverless AI, along with specific controls and granular controls, user controls, and permissions that IT often needs. I won't go through all the benefits here. Do you want to add anything?
Sure. So we built Enterprise Puddle basically to kind of let the IT and DevOps professionals provide almost a managed service for the internal consumers who are the data scientists, right? So typically what will happen is if you're setting up AWS access or Azure access for each individual user who will have to go into the console and then spin up machines. They will have to set up their own IAM credentials, provision the VMs, connect to SD buckets, configure or Azure Blob Storage, wherever the data is, and set those up. And this can be pretty time-consuming, not to mention non-trivial amount of like understanding, because if you're a data scientist or not used to cloud, the cloud sort of best practices, you may end up doing something wrong or spending a lot of time figuring that out. And often these things don't change. So with Puddle, what we're doing is we know exactly what driverless needs, or even H2O needs, right? So both for H2O and driverless AI, we have set up best sort of Terraform templates, AMIs, and packaged all those up so you can essentially provide an internal managed cloud for your users who can log into the cloud, and then they will have predefined instance types available that can be spun up with just a couple of clicks. And we'll show in the demo later at the end of the presentation how convenient that can be. The second big benefit is, of course, managing of resources, right? So you can specify how many access each data scientist has. So, for example, you want to allow only a pool of 10 machines with so many CPUs and GPUs for a group of data scientists. So you can specify that, and then that way, if someone tries to exceed it, the service will prevent them from doing that. And that's extremely useful to control the costs, which can be pretty significant on cloud. The third thing we do is we actually connect with your existing security credentials, whether it's LDAP or Kerberos or even Azure Active Directory or AWS IAM credentials. Whatever your security credentials might be, you can use the same for managing Puddle instances as well. Again, as Ronak highlighted, this exclusively runs in your VPC. So this is not a SaaS offering. This is a managed offering that you run in your own VPC. Extremely powerful, and we have a couple of really interesting customers now, large financial institutions who are using this to manage tens of users now on their AWS and Azure accounts. So they have, so for each group, they've set up a Puddle, small Puddle of sorts, and within that Puddle satisfies basically 5 to 10 users at a time, but this can very easily handle even hundreds of users for that matter.
Yeah, so this is perfect for environments where you don't want you want the data modeling and machine learning to happen within the enterprise without data going out of the enterprise. So within your VPC. And lastly, we have Steam here, which is very similar to Puddle, and so it has the same controls, same user controls and permissions, and the difference here is that you have the flexibility to spin up instances of H2O and run them as YARN jobs. So the management is through Yarn here.
Yeah, so Enterprise Team, as Ronak mentioned, is a similar product, but for on-prem, mostly on-prem management of H2O instances, H2O Sparkling Water clusters. So typically, you provision basically Steam to run on one of the nodes on the edge node, and give it a few nodes available. Again, these are provisioned through Yarn. So the neat thing about Steam is that once you set up Steam with user credentials, and you can just like a hurdle, you can also specify how many entitlements that each individual user or user group has. So for example, you can set up a user group of data called data scientists, and you can say they have access to say 10 nodes, and each node can have up to say 256 of memory. So you've essentially allocated the max cluster size for that group. And once that's done, every time someone comes into Steam and requests a cluster, they can specify that, hey, I need 4 nodes with say 100 gigs each. Steam will go to Yarn and provision a cluster, and then make a proxy link available for the user, so that they can just spin up, start accessing H2O Flow or even Jupyter Notebook. So we also give you Jupyter Hub out of the box, so you can start a Python notebook and then connect your H2O cluster and start doing your work. The same thing can be done for Sparkling Water as well, both for the external mode and the internal mode. So whether you're spinning up Sparkling Water inside Spark or as a standalone cluster, you can still use Steam to do it. And all the benefits that I mentioned of Steam will still apply. So again, you can connect to LDAP or other authentication mechanisms, and everything will be Kerberized. So even that, because you will be connecting to your HDFS as well through the Steam cluster, your data access credentials will be all carried over. So meaning when I launch and when I go to H2O through Steam, when I do it, try to load a data set from HDFS, I'll only see whatever is available to me as a user. So very secure, very convenient to, and from the DevOps people, there is a nice admin screen, so they can see at any point of time which clusters are idle, for example, or which clusters are active. And if there's a bunch of idle clusters, they can kill them or shut them down to give back resources to the rest of the folks.
I also wanted to mention that you can download any of these through our website. If you just go to the download tab on h2o.ai, you'll find all of these over there as well. All right, let's switch topics a little bit and show you how this is deployed, by our customers, and how would you use this in enterprises, right? So this is where this is an example where driverless is deployed in the cloud. So you have from the left to the right, you have data integration and sources essentially sitting in the cloud. It could be a cloud data warehouse like Snowflake, or and then followed by transformations and data quality checks by Alteryx. And these are all our partners. And the data is then fed into Driverless AI, where we do model development, feature engineering, and then once the winning model is back into the cloud. So, so like we mentioned earlier, this can work for any of the 3 cloud providers that you see at the bottom of the slide.
Yeah. So think of this as a reference architecture, right? So if you are doing, if you're a 100% cloud customer, and let's say you're using a cloud data warehouse like Snowflake, as Ronak mentioned, or it could be BigQuery for that matter, or Redshift. The neat thing is we have direct native connectors for all those cloud data warehouses, and also for all the cloud blob storages as well. So you can ingest data directly. We are also partnered with Alteryx, but I know in many cases you might just directly bring the data into Driverless, or you might take it to one of these data prep tools and prepare the data and then push it back either via the blob storage or directly, in some cases like Alteryx, directly into Driverless AI, because we have a native connector. Once it's in Driverless AI, the models can be built, and then the deployment, as Ronak mentioned, we'll look at that in a second. We have multiple modes of deployment. You can have one-click REST server that can be spun up on the instance itself, or you can deploy them into something like AWS Lambda, or into even something like SageMaker for that matter. Similarly, you can we have a whole series of Driverless AI deployment templates, similar ones for H2O as well. So this allows for deploying models in different environments. So you can do batch scoring, spin it up as a UDF, for example. And this is all enabled by the fact that both H2O and Driverless AI give you a Mojo, which is basically the seedless format that's highly efficient and built for deploying anywhere. So it is meant to be deployed standalone in whatever environment you're on, and it is doesn't have a lot of requirements or dependencies.
So lots of flexibility when you're running pure cloud deployments and multi-tenancy, security, and so on. All right, this is a hybrid deployment with driverless AI. So the difference here is on the left, where you have data sources sitting on-prem or part of it on-prem, part of it on the cloud, and you follow the same procedures. So again, the deployments coming all the way to the right, the deployment again could be in the cloud or on-prem using a REST server, etc.
Yeah, so this is a good example, and again, we want to highlight one other partner of ours, Blue Data, that we work pretty closely with, and they have a again, very nice product so that can manage provisioning of instances, resource management, orchestration. Yeah. Both they can do it both on-prem and cloud, and we work with a bunch of customers together with Blue Data. And the neat thing is both H2O and Driverless AI are available in the Blue Data catalog. So they are provisioned, they are ready to be provisioned. We make sure that we test and update the latest versions there. And so that's a nice way. And then the data access as well, if you end up using Blue Data's DTAP connector, we have a native DTAP connector into Driverless AI, so you can ingest data directly.
So very tight integration with Blue Data.
Yeah. And then similarly, you can we also have a very good integration kind of with IBM. So one of our large customers actually they use IBM's Spectrum Conductor. So that's a very again similar offering for orchestration and management of instances. So this is actually a really large organization with over 100 users of Driverless AI, who are all sort of being able to provision instances through the IBM Spectrum Conductor. So very convenient again. That Spectrum Conductor manages their on-prem data center, hybrid data center, and then spin up sort of their own sort of internal cloud for Driverless AI instances. And then, as Ronak mentioned, when it comes to deployment, you can basically deploy this anywhere, right? You can deploy these back into the cloud or on-prem. We have full flexibility as to where you can do this. And the same instance of Driverless AI, as just to highlight, can ingest data from different sources. You can actually import data from Snowflake and also from HDFS if you're running on-prem. So you can set up both of those things.
Yep. Again, lots of flexibility in hybrid environments. And finally, on-prem. This is where this is in cases where you haven't yet moved to the cloud and you're completely on-prem. And so this slide shows you that we can connect into any of the HDFS Hadoop distributions, as well as leverage NVIDIA's latest GPU hardware, Intel hardware, as well as IBM. Anything else you want to add here?
Yeah, this is again true for both in cloud and hybrid as well, right? We partnered both with NVIDIA and Intel to make sure that we can optimize and accelerate all of our software on the latest GPUs and CPUs. That means that as a customer, you will get access to the when you upgrade to the latest hardware, our software is guaranteed to be optimized for that. So you will get speed benefits so that on the same amount of hardware, you can now support more users. You can actually run more experiments. So that's an important part, right? So because that can be a huge cost saver, because if you're highly inefficient, or if software cannot take advantage of the latest advances in hardware, you basically will be needing to keep scaling up or keep scaling out because the software is not optimized. But whereas because we are optimized, we are able to give significant speed benefits in the order of anywhere from 5 to 30x faster on the same GPUs and CPUs that others may not be able to. So this means that you can provision fewer instances or fewer GPUs and still be able to get the same amount of performance.
Yep. All right. So hopefully you get a good sense of the flexibility in the platform, as well as seamless integration that you get with Driverless AI. All right, moving on to very quickly before we jump into the demo, just wanted to talk about a customer, G5. You can look them up at getg5.com. They're essentially a real estate marketing company. They're purely on AWS, Theory Cloud, and the use case was around essentially lead scoring. So they essentially make life easier for the real estate professionals as they call people and try to get more and more business for real estate companies. The idea was to essentially screen through the head scored calls, and so those were basically the features. So H2O was used for using the word-to-vec model, and then so this slide shows the data to prediction cycle, which is essentially creating the model, creating the call scoring model using driverless AI on Amazon EC2. And then this slide shows how this was deployed using Lambda, and so as the calls come in and the metadata is fed into the production model, the call scoring model, which is deployed in AWS, the agents get real-time score of the callers, of the customers. So now they have a very good understanding of essentially an intelligent lead scoring of the customers calling in.
Yeah, this is a great example of what we can do when, especially we can fit in with other tools in the ecosystem, right? So in this case, they use both H2O open source and driverless AI, and in addition with AWS's transcribe functionality. So they were able to bring in call recordings, wave files directly into AWS Transcribe, get the transcripts, and then run through word2vec from H2O. Because H2O and driverless AI both support the Mojos, they were able to take the Mojo artifact, use that to score and create new vectors, give it to driverless AI to build models, and then take the final Mojo and then deploy it into AWS Lambda. And the neat thing is, and like in the slide just up right now, all of this was achieved in a matter of a couple of months. So this is they had a reasonably small team that was dedicated to data science and machine learning. So they were able to put this entire pipeline up on cloud in just a matter of months, and they got significant savings, like nearly $1.5 million, $1.25 million saved per month purely on calls, right? And they were handling up to 1 million calls per month. So being handled and significant amount of savings, all done through AutoML and also by using all the tools that we are able to provide. So this is just an example of what you can achieve very quickly. So this doesn't have to mean that like a year-long project. This can be done like a matter of months, tested, validated, and deployed into production.
Yeah. Awesome. Without further ado, let's switch into the demo. Okay.
Hopefully you guys are able to see my screen now. Perfect. So let me first jump into show Enterprise Puddle. So Puddle is basically the managed service for both H2 and driverless AI instances on cloud. This is obviously a version of ours that we use internally, but when we work with large enterprises, we can set this up in their own VPC for them, so they can have their own Puddle environment for data scientists. So a couple of things I want to point out, right? So obviously I have a couple of instances. We'll look at the demo in a bit, and once I go to this instance, I can actually see all the details of that instance as well, right? So so I can start a new driverless or H2O instance. Let me click on this. So let's say I want to create a new driverless AI version. I can pick the version of the software. So all the previous versions are also available. So this is really neat because as an IT DevOps person, you can make sure that make available all versions that are supported in your organization. So the data scientists can go back and forth if they need to. It's very easy to spin up an instance, shut them down, go back and forth. Once you pick an instance, you can give it a name. So I can, let's say, Vinod demo, and then you have the ability to pick instance type, whether it's CPU or GPUs, and this is all completely configurable. So you can, in the administration, when you configure it, you can set up to ensure figure out what type of instances are available. So depending on your IT budget and your constraints, you might offer big, large instances and small instances. And this is also configurable at a user level. So you might say that, hey, this person, I might say Ronak has access to, say, these 2 GPU instances, whereas the other user may not have access, may only have access to CPU instances. So you can have a differential sort of entitlements across the organization.
Fine user controls.
Exactly. And then you can specify the type of volume size. Again, whatever options are showed here are all configurable by the user. And then this is a really neat feature, especially for cloud, right? Because there is an auto shut off if the instance is idle for either an hour or 30 minutes, depending on what the user picks. Now this is really important. We've seen a lot of horror stories from customers where someone spun up a GPU instance or a large GPU, like with multiple GPUs or multiple CPUs, started an experiment and forgot to turn it off overnight, came back next day or so, and they were slapped with a huge bill. We have had customers who have had like massive, in a month, they ran up like hundreds of thousands of dollars just by a few data scientists forgetting to turn off their instances. So that we built this especially to avoid those kind of scenarios, right? And the neat thing is because we have fine-grained control into the instance and we know exactly what's happening, we are able to do this much better than what you could set up from, like, say, cron job, because we can actually know when driverless storage 2 completes the experiment and we can automatically shut it down. And not just have to look at the instance at a higher level. And you can provide any annotations. So I'm not going to create an instance because I already have 2 running. And similarly, you can do the same for H2 as well. You can pick up an instance type, you can give it a name, pick the cluster or the instance size, and then annotate it. On the admin side, let me show a couple of things. You can control the users, you can control the systems, and let me click on systems for a second, right? So, and then actually, you can specify which are the users who are using it, and you can pick it up. More importantly, let me go to the AMIs. So this is actually where you can control what instance types and what AMIs are enabled. So at H2O, we provide a whole bunch of AMIs for customers. So each of these AMIs are published by H2O itself. But some of our customers are essentially taken our AMI and made a few modifications or added a few controls that they wanted, and they can basically publish their own AMI, which can then be used for Puddle as well. So part of the thing we do when we work with your organization setting up Puddle is work out what are your approved AMIs, and then make sure that those are enabled. And within AMI, you can specify whether you want to sort of enable Jupyter notebooks, for example, or you want to enable security, or which ones are disabled or enabled. So a lot of control for the DevOps and IT people. They can set it up. In addition, we also give you access to a dashboard. We call it Puddle Stats. And Puddle Stats gives you sort of like a high-level view of all the different instances that are running at any point of time. You can also get a sense of the cost that we are running up. So you can say that, hey, these H2O Developers instances are costing, say, $5,000 total in this time period. And then that can allow you to control your costs if they are going out of control. Okay, so now let's go ahead to this one instance that I already spun up a little while earlier. So when I start an instance, after it starts, this is what I see. I see the URL for the instance. We'll go to that in a second. The username and password are created. This is again configurable. Right now these are created by default, but you can have these be your Azure Active Directory credentials or AWS IAM credentials or LDAP. So depending on whatever authentication mechanism you use, we can pass those authentication credentials over here. This is neat. This is the config TOML file. This allows me to go in and specify the things. So for example, if I want to start enable the Snowflake connector, I would do it over here, and I would provide whatever credentials I need to do. So you can update the config TOML file very easily. You also have the SSH key actually. So if you want to actually SSH into this machine, I can do that with this command using the SSH key. If I want to do something in the instance, I'm allowed to do that. So you get full control as well. And then you can also get a quick sense of all the different models that have been run. This is a very high-level view. So even before you get to the actual instance, you can actually see what's been happening in this instance, and I can see what the status of the job. So I might have started a few jobs overnight, and then I can come and see what progress they've had, right? So this is actually, again, very useful, and you can get a quick read on the system metrics as well, if the CPU is being highly utilized or not, okay? So let me jump into the instance itself. So this is Driverless AI. So once I took the URL over here, popped it to a new window, this is what I get. I'm in EC2 obviously. And I can pull data from different sources. Obviously I only enabled a few, but as you can see, I can pull data from S3 or from HDFS as well. So I can do pull data from on-prem or cloud, or upload the file directly as well. So with multiple ways to bring data in. Once the data is in Driverless AI, you can obviously run through whole modeling workflow. I'm not going to spend too much time doing the modeling because you can see that in other webinars, and we have covered this pretty extensively in the past. But let me just go in very quickly to a couple of things. So once the data is in here, let's say you built a project for doing the machine learning workflow. So let me pick this one. So you have a data set, you have multiple data sets for training and test, you build a whole bunch of experiments, and building an experiment is very easy. You just click predict, you load up the experiment, you can use the wizard if you want, if you are new to the product, but if not, pick the target column, weekly sales in this case. You can put in a test set. Again, it smartly recommends the test set that's available in the folder. And then since the time series problem, I would specify what the time column is. And then after that, I have the opportunity to specify the grouping, so I'll let the software pick automatically. I can specify the horizon for the forecast and the gap as well. And then the three knobs for accuracy, time, and interpretability are all I need to change. I can let me pick those, and I'll launch experiment. And it'll go through the entire workflow first by checking for usage, any differences in the data, distribution shifts, any null values, missing values, and then apply data fixes. So you can see it detected a bunch of distribution differences between the training and test sets, and it's giving us warnings about those. Depending, you can turn on the warnings, or you can even force a high level of permissions for Driverless. In the expert settings, you can say, tell it to drop these columns if you want, if it's very different, for example. So all these are configurable over here. We also provide leakage detection. So for example, if you have a highly leaky column, it will give you a warning saying that, hey, this column is leaky, consider dropping it, for example. Then you can obviously control the different algorithms that are available, what you want to include and what you want to exclude. Similarly for time series, you can include things like what kind of lags are allowed and what lags are not allowed. NLP itself has a bunch of different algorithms like CNN based on TensorFlow models, Big-O TensorFlow models, and then character-based CNN based TensorFlow models. In addition, you can also bring in your own pre-trained embeddings for your own corpus of text and upload it over here if you want to. On the system side, you have a lot of fine-grained control on how many cores to use per experiment, how many GPUs to use, if they're available, and then if you want to enable detailed traces. This is extremely useful, again, to see at a lot of detail what is exactly happening in every step. Similarly, recipes can also be controlled. This is a really neat feature of Driverless AI that was introduced in one seminar. And then the model management, the remaining parts of it, you can control all the config toml and whatever strings. So you can add in some additional config if you want to. So while this is running, we can see what features are getting generated as they're being built. All of the target lag features are coming out as significant, and you can actually look at what those mean in some of our other webinars. I want to point out a couple of things from an IT perspective. So everything we do is being logged over here, and full system level logging information is available. And this is exactly what we have access to as developers too. So you can go back and always look at what happened. Similarly, the trace, we only have simple trace enabled, but you can enable detailed trace as well. So when we enable that, you can actually go to every single cell and see what is exactly happening, what transformation. So for example, if you think that the experiment is running for too long, is stalled, you can actually see in a lot of detail as to what exactly happened. One of the neat things with Driverless AI is the ability to finish or stop an experiment and say, let's say finish. It'll finish the experiment, but more importantly, I will have the checkpoint available. So I can do the same checkpoint. So this is neat. It's a nice way for debugging your models and then restarting after making your fixes. Let me go now to an experiment that we finished earlier, the same data set, and quickly show you what happens after it's done. So once the model is built, you will see the experiment report being published, and this experiment report is a really nice and easy way to actually see what's happening in your data set, and this is actually very useful too. So as an end user, you can basically see an experiment summary being created like this. It has all the information that happened under the hood, and you can open this report that gets generated, which is basically like a 20 to 25 page report that tells you all the information around what happened in the experiment, what data set was used, the settings of Driverless AI, the version of the software, the system specifications, all the training data and test data paths, and some summary statistics on the input data and all the shifts that we talked about, right? So this is very useful again for governance purposes. So if you can capture this entire report, keep it along with the experiment, and you can always go back and see what happened. So really useful for lineage and governance of what exactly happened. And along with that, you can see other information on what treatments were done on the data, what features were generated, and how many models were built. So really nice report. I won't go into a lot of detail. We have again a lot of a complete webinar on this if you want to understand more about what this report can do. One thing I would point out is we can completely customize this report based on your requirements. So as an IT organization, you can specify what needs to be maintained for our governance purposes, and we can customize this report to look like that. Jumping back to my instance, let me go to another experiment which finished a little while earlier. So this now, I can obviously interpret this results, and this is, we have provided a lot of functionality around explainability and interpretability that's extremely powerful. We have a lot of good info on that if you're interested in that topic. The neat thing I want to find out is the ability to now download the Python or Mojo scoring pipeline. So this basically provides you the entire pipeline, including the feature engineering and the models that got created, which are ready to be deployed in different environments. And we provide the ability to deploy it in Java. There's a Java runtime, there is a Mojo 2 Python runtime, and the Mojo 2 R runtime as well, in addition to an R and Python client. So for your data scientists, and data scientists obviously come in different flavors, right? Some of them swear by R, some of them are Pythonistas, and then many others who basically want to work directly in Java or somewhere, right? Java, or there's others who are like the GUI. So with Driverless AI, and both H2O and Driverless AI, you have the ability to now provide your data science users the flexibility of where they want to, which environment they want to work in. Their work, all the models they produce, all artifacts they create will all still be available in the same format, irrespective of whether they use the R client or Python client. Similarly, the Mojo runtimes are just wrappers for the core Mojo, which itself is the same. So you can version the Mojo files, and then you can provide these runtimes on demand when they are doing scoring. So
just one more addition to that. So think of your enterprise running tens or hundreds of applications written in all kinds of programming languages, regardless of what they are and which language. You can take help from this part of the demo, this part of the Driverless AI, and get Mojos in Java, C, C++, and essentially integrate those models into the production applications.
Perfect. Then one final thing I want to show is click on deploy. So when I click on deploy notifications, I have the option to do AWS Lambda. So this is a really neat way to launch on cloud. So I can use my AWS existing environment variables, specify my access key, and then pick the region and deploy, and then deploy directly into AWS Lambda. So very quick way to launch an endpoint. I can also do a local rest point. So actually I can just specify the port number, I can specify the maximum heap size, and then hit deploy. And this will basically deploy the model that we just built as a local rest endpoint. So it's again a very quick way, an easy way to do one-click deployment of models and prototype them, test them very quickly. Obviously, instead of, you may not this may not be the most optimal way for production deployments, because you want where your training is running is not where you might run your production. But you can take these deployment templates, the REST and Lambda, and other deployment templates that we published. And let me show you that in a second. Over here. So there's a GitHub repo called DAI Deployment Templates. It's open for everyone to see. And we have published, basically, as you can see, a whole bunch of different deployment templates: AWS Lambda, KDB, local REST server. It's very easy to use. So we have Swagger templates available, so you can take these to publish your models. Instead of running this locally, you can run it on a different instance. So this is maintained by us. I also want to point out that on our documentation, go to docs.h2o.ai. Let me go back and show that real quick. This is where you come to documentation, pick up and view the documentation, and everything we covered today and more is available. So there's a full setup on configuration for how do you install and configure H2O and Driverless AI in different environments, whether it's on-prem, cloud, IBM Power. You have similarly how to set up environment variables. So this is something that's really useful if you are spinning up for a lot of users using containers. You can specify all of those things. Similarly, the data connectors, when you set it up either through Puddle or through Steam, or even you're doing it individually, you can specify all the different data connectors, and enabling them is super easy. Once you enable them, all users in your organization will have access to them. So that's again a neat way. So you don't have to teach every data scientist how to do this individually. And then similarly, deployment of these modules is very easy as well. So as you can see, there's a whole bunch of explanation on how to deploy them on Lambda and then for REST endpoints. So that's pretty much all the things we want to cover. Oh, there you go, hooray. The model got deployed when you clicked it. So as you can see, this is the endpoint, this is where the model is running, and obviously this is localhost, right? So I can actually take this curl command and try it on an endpoint. I should be able to get a result. So very easy to test out your endpoint is working or not.
Great. So this hopefully gave you a really good view of how you can use driverless all the way from, download it, use it, create instances using Puddle, to create machine learning models, and deploy them. So, we consider this a very easy to use software, and that's how it's been designed. And that's all we have.
Okay. At this point, maybe we'll open it up some questions. If there are any, please feel free to post your questions in the channel.
Yeah, while we're waiting for questions to come in, I just want to take this time to remind you all that presentation slides and the recording will be made available on our BrightTalk channel. So be sure to just visit the same link that you did to access this webinar to get those materials after the presentation is over.
Okay. Yeah, it's just so one question I think we've been asked quite often, came up as well, is how do you enable basically good provisioning, sort of best practices around provisioning on different cloud environments and managing those versions, right? So obviously you have now different clouds: AWS, Azure, GCP, Oracle, and multiple ones. And I think really the answer to that is I want to point out that go to the h2o.ai/downloads page, you'll see a whole bunch of different AMIs and templates being published by us, and we maintain them for every version. So we do have two sort of streams for driverless especially. One is the long-term stable stream, LTS releases, and then there is a latest stable. So a lot of our large organizations, the recommendation is often to stay on the LTS stream. That is tested, validated, it's robust, and we will continue to support any bug fixes, bugs or hot patches for at least 12 to 18 months. So that's often a very stable stream for large enterprises to be on. And so if you want to set up an enterprise-wide sort of cluster or environment, that's a good place to be. For a lot of customers who are interested in the latest features and who want to try out the newer products very quickly, the latest table which stream is often a good place to start at. And even that is well tested and maintained, but that we continue to add more features at a rapid pace there. So recommend using those templates directly from our page. If you go to h2o.ai/download, you'll see the options to download and play with every single offering that we talked about today.
Okay, great. Not seeing any more questions come up, so just want to say thank you to Vinod and Ronak for taking the time today and doing a great presentation. And thank you all for joining us as well. Have a great rest of your day.
Thank you.
Thank you.